A unit circle is a circle of radius 1. So it's 1 unit. It doesn't matter what the unit is. It could be 1 millimeter, 1 meter, whatever. Now, the unit circle is shown on the XY coordinate plane. We are going to be interested in the coordinates of a point on the unit circle. We will relate the coordinates of a point on the unit circle to angle theta. Theta is measured anti-clockwise from the positive x-axis. So here's the positive x-axis. So we're measuring in this direction from it. Now, in this video, we are only going to look at acute angles. That is, angles in the first quadrant, this quadrant up here. Acute angles are angles that lie between 0 and 90 degrees. So we're going to look at an angle ranging from 0 degrees all the way up to 90 degrees. Here's an example. Theta equals 30 degrees. Notice that if we take the two short sides of this right angle triangle, their lengths are given by the coordinates of the point. The side adjacent to theta in this right angle triangle is the x value of this point, and the side opposite theta is the y value of this point, 0.5. Here is the general picture for a point in the first quadrant. So the coordinates are x, y. So that means the horizontal distance of the point xy to the y-axis is x. The vertical distance is y. That's the distance of the point to the x-axis. Now in this right angle triangle, we can apply some basic trigonometry. We know that the side opposite theta is y, the side adjacent to theta is x, and the hypotenuse has a length of 1. Of course, the hypotenuse always has a length of 1. So I can vary theta, and you can see that x and y are changing, but the hypotenuse never changes. So we have these relations here. The cos of theta, as we know, is adjacent over hypotenuse. That's x divided by 1. But x divided by 1 is just x. Sine of theta is opposite over hypotenuse. That's y over 1. But y divided by 1 is just y. So we can see that we can replace the coordinates of this point with cos theta, sine theta. Cos theta is x, sine theta is y. So now we get this picture here. We can also see that both cos and sine of theta are lying between 0 and 1. The lengths of those two red lines always lie between 0 and 1 for angles in this quadrant here. Well, the values are lying between 0 and plus 1. The two short sides of a right angle triangle are always smaller than the hypotenuse, or the longest side. So we have these relations here for angles theta in this quadrant. So the first number here is the cos of theta, and the second value here is the sine of theta. So for 30 degrees, we see that the cos of 30 degrees is 0.866, that's the 3 decimal places. The sine of 30 is 0.5. Let's bring theta down to 0. So the first number is the cos of theta. We can see that it's 1 here when theta is 0 degrees. The sine of theta is 0 when theta is 0 degrees. Let's increase theta. Now I'm increasing it here in units of 15 degrees. So we can read off the cos and sine of 15 degrees. And so on. We can keep on increasing theta. Here theta is 60 degrees. The cos of 60 is 0.5. The sine of 60 is 0.866. We can keep on doing this until we get to 90 degrees. In this case, the coordinates of the point P are 0, 1. So that means that the cos of 90 degrees is 0. In other words, the adjacent in this triangle is actually 0. So we have 0 divided by 1, which is 0. The sine of 90 degrees is 1. So that means the side opposite theta is actually 1. And the hypotenuse is, of course, 1. So sine of 90 is 1 over 1, which is 1. Let's take a look at tan of theta. We know that that's opposite over adjacent. When theta is 0 degrees, then the side opposite theta is actually 0, and the adjacent is 1, so it's 0 divided by 1. Basically, we're just putting sine theta over cos theta. See, y over x is just sine over cos. That's what tan is, sine over cos. If we increase theta, you can see that the tan is increasing. It increases to 1 when theta is 45 degrees, opposite over adjacent is 1. We have this isosceles triangle. If we keep on increasing theta, we can see what's happening. We can see that the value is getting larger and larger. And it's going to go off to infinity as theta approaches 90 degrees. When theta is 90 degrees, we have effectively division by 0. The opposite side is 1, or y is 1, so we've 1 over 0, which is undefined, or we can just say infinity. So tan theta ranges from 0 to infinity, as theta ranges from 0 to 90 degrees.